to the new video. In this video, we are going to talk about exploratory data analysis on iris dataset. First, we will see what is iris dataset. Iris dataset is a dataset of flowers which consists of three different types of flowers, that is setosa, versicolor and virginica. And this dataset has four different attributes, features we can say, which consists of ID, sepal length, sepal width, petal length, and petal width, all in centimeter. You must be wondering what is these features. So first let me go through you iris data. Okay, so basically this is the petal length of a iris flower, and these are the sepal length and sepal width of an iris flower. So basically these are the length and width of both sepal and petal, and on the basis of these flowers are classified into three major categories, that is setosa, versicolor and virginica, on the basis of these features or attributes, or you can say dimensions. So class label is a dependent feature and these are the independent features. Okay, we have the basic understanding of our data set. Let's get back to our Jupyter notebook. You have understand about the iris dataset. So next thing in your mind will be where to get this data. So this data is freely available in Kaggle. You can download it from here. Also, I will give in the link in the description box from where you can download this dataset. Okay, after downloading this dataset, getting back to our Jupyter notebook. I'm using Jupyter notebook. You can use other notebook or whatever you like to. Okay, before starting our case study, let us understand the objective of doing our case study. The objective is to classify the species of iris flower on the basis of data we have. Like, the species are of three different types. Let me show you. There are three: setosa, virginica and versicolor. So our objective is to classify these flowers on the basis of the data given. Okay, so this is our objective. So let us jump into analysis of this data set. So first and foremost step in any case study of data science or data analysis is to import necessary modules or libraries which are built in Python. So we are importing pandas, matplotlib.pyplot, seaborn, numpy. We will go through each of these libraries one by one. Pandas is a library which is used for manipulation data and data reading and data input, etc. Matplotlib.pyplot is a library which is used for visualization and plotting graphs and tools and etc. Seaborn again is a tool for visualization. Numpy is used to play with arrays, numbers, as its name suggests. It's number Python. Okay, so we have a basic understanding of these libraries. We will see more about them when we go through the case study. After we have imported these necessary modules, let's read the data. So my data is already installed in my laptop. So using pandas, I'm reading my CSV file. CSV, if you don't know, CSV means comma separated values. Means that these values, ID, sepal length, sepal width, petal length, these are separated by a comma. Let me show you more about example of a comma separated value. Comma separated This is an example of comma separated value where hop revert comma 34 comma 30 20. So you must be understanding how our data is stored in a CSV file, that these are separated by a, these datasets sepal length sepal width all are separated with a comma. So using pandas we can read the CSV file. So we have read it here and stored in the df. I'm using df, you can use any other word. Let's say we use our data. Okay, no, let it be df only, data frame. After we have input our data, let us first get the head of our data. This step is important because in this step we immediately get the gist of our data, like what is present in our data, the all the features, the columns, we get it immediately in this. So after printing the head, we see that there is given id, sepal length, sepal width, petal width, and the species to which the flower belongs to. After this we print the columns, which is again we see what columns are present. We see that there is centimeter, centimeter, centimeter. We know that it is centimeter, we don't need it and write again to. Just to simplify, we are renaming these columns. So df dot rename dot columns is bracket columns, just rename using dictionary. And the next step is df dot describe. Okay, this is a very important step. This single line of code will help us a lot in data analysis. So we see that this single line of code help us to get the maximum value, minimum value, mean, count, standard deviation, minimum, and 25th, 50th, and 75th percentile on also. So let me give you a understanding of this. Like we have sepal length, so we get to know that the maximum length of sepal length is 7.9, minimum length of sepal length is 4.3, mean is 5.8, standard deviation is 0.8, count is 150. 75% means that 6.4 is the 75th percentile, means that 75% of the flowers have length less than 6.4. So this is the use of describe function. It gives the gist of, and it describes the data very well and gives the basic stats of a data immediately, like mean, median, mean, standard deviation, max, minimum value, maximum value, which will give a great help to understand about a data set. After this I have to know how many rows our data set contains. Columns, we know that it contains of 6 column like id, sepal length, and but how many data points are there? Like so, df dot shape gives us. It shows that there are 150 rows, 150 different flowers, and which are separated into 6 different columns. Next steps is to df species dot value count. So I want to know that how many different species are there, like how many flowers are there for setosa, how many there for virginica, and how many there for versicolor. So I use a simple function df bracket species dot value counts. So it gives us a count of all the different classes of flower, that iris setosa is 50, virginicolor is 50, virginica is 50, and versicolor is 50. Okay, so we see it is a well balanced data set because all the different species are divided equally 50-50-50. So it is a well balanced and structured data set. Okay, plot. So this is the very first basic plot of two features. We are plotting here two different features, that is sepal length and sepal width, using a scatter plot. Scatter means that all the points are scattered according to their length and according to their width, as shown below. They like that. In x-axis we have sepal length, in y-axis we have sepal width, and we plotted using a matplotlib function. Okay, but the problem is here, but using this we can't find out which category, which species of flower it belongs, because all of the points are of the same color. We cannot determine which category of flower belongs to which. Okay, so what can we do? So here can be seaborn. Seaborn help us to get the colorful scatter plot. So we use seaborn set style white grid. White grid means the grid which we can see here is behind this, like it is white grid. Facet grid, like grid like structure. TF is the data set we are using. Hue is species. Hue means here that the on the basis of which we are scattering, or on the basis we are categorizing our flower. So here we are categorizing on the basis of species. So we are here, hue is species. Size is again to determine the size of the figure. So let's plot it. Plot dot scatter. X-axis we have sepal length, y-axis we have sepal width. Add legend. Legend is this species Iris setosa, which tell us which color belongs to which species. And again using matplotlib plt dot show, we get this. Okay, there is some error. Let me check. Okay, I have not run it properly. Maybe. Wait a second. Yeah. See, now you see that with the use of seaborn, we have a colorful scatter plot. Here we can see that set. Here is this setosa, and orange orange color is versicolor and green color is virginica. So if the let's say that if the length is less than sepal length is less than 4.5 or 4.7 and sepal width is 3 to 3.5, our flower is setosa. Okay, but here you can see that setosa is properly dividing with versicolor and virginica, but we can't divide versicolor and virginica because they are completely overlapping, with some points are there, some points are here. We cannot make out or classify the type from only seeing this. So this is a two-dimensional scatter plot, which is helpful in a way because we were able to somehow able to divide the setosa flower from the versicolor and virginica. We will somehow find the ways for dividing versicolor and virginica also in given below methods, but for now it is this 3D plots. So now you have seen two dimensional plot where we use two features, our sepal length and sepal width, and plot the scatter plot. But is it possible to plot the three-dimensional plot? Yes, it is possible to plot a three-dimensional plot. I am showing you the very well done implementation by plotly.ly chat. We have done a 3D plot of a iris dataset. Here you can see that there are three features: petal length, sepal length, and sepal width. These are awesomely arranged and you can play around. I will give the link in the description box. You can see that three features are there on the x, y, and z axis, and you can see that every point have the x number, y number, and z number. So using this plot, we can plot the 3D plot also. But the problem in this is that lot of mouse interaction take place. We have to move it from here and here to see and visualize our data because it is not a two-dimensional. Okay, let's get back to our Jupyter notebook. The 3D plots. But what about 4 dimension, 5 dimension, n dimension? Can we see 4 dimension, 5 dimension? A normal human can only see up to 3 dimensional. 4 dimensional, 5 dimensional, we cannot visualize it. So, but our data set will not only contain 3 dimensional data set or a 4 dimensional data set. It will contain n numbers of dimension, n numbers of features, such as 100 features, 1000 features. In complexes, there are tons of features. What will you do there? How will you plot them and how will you visualize them? Is there any way to do it? Yes, there are many ways, and machine learning is all about these n dimension data set because the this data set is very basic data set. This you can also plot on a graph of paper and do it. There is no need of a machine learning here. But for complex dataset, we will need more techniques and tools to do this, which we will see in upcoming lectures. But for now, beginning with data science, this is essential, or you can say a very basic data set to understand and to get familiar with tools and how you do the analysis. So now next is pair plot. So there are four features we have: sepal length, sepal width, and petal length and petal width. Can we plot all of them all along in a single graph? Yes, there is a way. Using seaborn pair plot, we can plot all the features in a single, and you can visualize this perfectly. Here you can see it. Like, see, y-axis have sepal length, sepal width, petal length, and x-axis have sepal length, sepal width, petal length, and petal width. Don't worry about these. We will see them later. Don't bother about them. Let's see them. These are the scatter plot. Let's see. Sepal width, like this is on the y-axis. So we will say, see here, sepal length here is on the x-axis. So this let's see, this graph has its y-axis as sepal width and x-axis as sepal length. This graph has its x-axis as sepal length and y-axis as petal width. This graph has his y-axis as petal length and x-axis as sepal length. I doubt you are getting it. Like, for example, this graph has a y-axis petal length and x-axis as sepal width. For example, this graph has a y-axis as petal length and its x-axis as petal width. You can see that for all the combination of features, we have built a graph. And don't worry about these diagonal graphs. These are histograms, or you can say PDF. PDF means probability distribution. And we will see in the next section what are these. So basically, we have plotted all the features in a single graph, and we can visualize each of the pairs of each of the combination of features from this graph. Like, let's say we want to analyze this graph for petal width and petal length. So the length, the flowers whose length is less than 2 and whose height is less, petal width is less than 0.5 or 0.6, we can say that this flower belongs to setosa. Similarly, we can say that the versicolor and virginica are also getting divided a little bit. There's a overlap in between, but not so much. You can see here that this is overlapping here, this is overlapping here, but still we can divide it using an simple if else condition. So visualizing it, we can come up to three conclusions, which I have written below. That petal length, petal width are the most useful feature to identify various flower types. Why? I've shown you like this. This graph is the most important because it's perfectly dividing the three different types of flowers. Yes, of course, there is a some uh, some overlapping here, but data science or data analysis is never 100% perfect. There will be some error, but up to some margin, this is accurate that it is able to categorize the three different types of flower into three categories using this graph. These two features, petal length and petal width. Next is, while setosa can be easily identified linearly separable, virginica and versicolor have some overlap as I have shown you. Third, we can find lines and if else condition to, we can build the lines and use the if else condition to build a simple model to classify our flower types. So we can use here our simple if else condition and classify different types of flowers. Pair plot, we have seen that these diagonal graph, which I have told you tell you later. So let us understand what are these graphs. So In statistics, or there are two terms, histograms and PDFs, which are widely used in data analysis. So first, let us understand histogram. A histogram is a bar graph of raw data that creates a picture of data distribution. The bars represent the frequency of occurrence by classes of data. A histogram shows basic information about the dataset such as central location, width of spread, and shape. Like here, we see. Like let y-axis is our count and x-axis is our petal length. So these bar plots are basically telling the spread, telling the frequency, how many in the range of this, how many data points are present, like in the range of 4.1 to 4.2, how many data points are present there, like 0.6. This is the count axis. Like for this, in the this have the very high count, like this have 3.5 count for the length of petal length 1.5. There are many flowers present whose length is 1.5. There are many flowers whose petal length is 4.7. So this basically gives the distribution of data, how many points or the frequency of data points present in a given range. So histogram is this basic bar plot. So what is PDF? PDF is a simple term probability density function. Again, from its word we can understand it is giving the density of, we can say, the how many points are present again in the range of the, or we can say the smooth form of histogram is called as a PDF. Like you can see these are the bar plots, and the smooth curved over it are called as a PDF. These PDF gives a very basic idea. It tells about the central tendency, like it is the, like in the middle where it have the top values, these are the central tendencies of, this is the central tendency, like mean median of the petal length. This is the mean of, this is the mean of virginica, this is the mean of setosa. So using histogram and PDF, we get to know about the distribution of dataset, their central location, and also this wide breadth of spread, like the range of values of how much they are spreading. Like you see that for setosa it is very steep because they have a less range, but for our versicolor it have a huge range, and for virginica it have a good range. So it also give the range, it also determine the width of spread, and also the shape of our data set. It gives us the shape of the, and we also get the visualization of the intersection of two data set. Like here, like we have versicolor and virginia, both are overlapping here, so we get to see this. So basically seaborn, we can plot the PDF and histogram using seaborn, which is a simple function SMS distribution plot, and for which we have to plot is petal length, add legend, and using matplot we have plotted a histogram and PDF. Similarly for petal length we have done for petal width, see, for sepal length, and similarly for sepal width and petal width. We can see that uh, this graph, petal length is a bit useful because there is a less overlap here. This graph is also useful because it has lesser points here, but again it is a bit useful. This graph, this is not useful because we can see that all the points, a sepal length is not a much useful feature because all the points are overlapping from each other. Again, this is also not a good idea. Sepal width is also not a good idea because all the points are overlapping with each other. So you see that using these plotting tools, we get the idea of data and the its analysis, and how the range of how, what is the mean, and how can we separate our how can we classify our data set. See, using simple analysis tool we can we have come to the conclusion that we can class, okay, that the range is, if the range is between this and this, we can classify the flower into setosa, versicolor and virginicolor, seeing the, by only seeing these visualization plot. Okay, next, a very interesting plot is box plot. Using box plot, we can get to know the mean value, the minimum value, and the maximum value as shown below. Using seaborn, we can plot the box plot like this: SMS dot box plot. Is our species. On the basis of our species, we are plotting, and we are plotting with petal length, and our data is DF and PLT dot show. So let's see. For like see, iris setosa, our minimum value is this point, our maximum value is this point, and this is the middle line in between is the mean value. Let's see this one. For versicolor, it's quite clear that this is the maximum value, this is the minimum value, and this point is the mean value. Mean value, or you can say that is the 50th percentile, and this is the 75th percentile, and this is the 25th percentile. Percentile means that it is a range, like if we say that 25th percentile value is 4, so the uh, iris versicolor species, the 25% flowers have a length less than 4. If we say that 75th percentile is 4 point, let's say 4.6, so 75% of flower of versicolor species have a length less than 4.7. So this is the meaning of percentile. So using a box plot, we can see that we get the minimum value, maximum value, these are called whiskers, and we get the mean value and the 25th percentile and the 75th percentile. So this is the use of box plot to get the min, to visualize basically the mean, and get to know about the data sets and how it's ranging. Similar to box plot, there is a violen plot. Violen plot is a combination of all the two previous, that it also include the box plot and our histograms, or you can say PDFs. It also includes our PDFs. So Seaborn also provide violen plot, like similarly we have done earlier. We can see that. See, this curve showing here is the our PDF. This is our box plot. The white dot here is showing the mean. This is the maximum value, and this is the minimum value for all the three categories of a flower. So we are done with this case study. We have covered almost some basics of exploratory data analysis, which uh, one must know when you are starting getting into data science. Okay, so in this video we have covered the basics of EDA, which is mostly used in data analysis in every case study of data science. But it is only a part of EDA. There is much more tools, much more to do, which cannot be covered in a single video. So this is just for your reviews. If you like this video, do let me in comments that what are the drawbacks and what are my positives and negatives. Do tell me in comments so that I can work on them and post another videos accordingly and with more contents. Okay, that's all for today. Thanks for watching, and please do share with your friends and subscribe my channel. Thank you all for watching. Bye.